Hello guys and gals. This is a video then to introduce the idea of isomers and isomerism and to set you up with the different types. So I hope you're watching this as kind of your first activity for the lesson this morning. Watch this video and then have a go at filling in the worksheet. What I'm talking about now should help you fill that in. Okay, so to start with, to define the idea of an isomer, as you know, I love my Lego. I'm just going to show you two Lego models. Okay, so as you can see, this model and this model contain exactly the same bricks, but then the models aren't the same. So we've got the blue bricks the same, the green brick is the same, and the red brick's the same, but they're configured differently. They've got different structures, or perhaps they've been put together differently. These are Lego isomers, okay? And in chemistry, instead of the different bricks, we're just talking about different types of atoms and the way they're put together. So in the same way that these are isomers, we might have a molecule containing some atoms, and then we might be able to take those same atoms apart and re-put them together in a new way. And what we have are two isomers. They contain the same number and types of atoms, but they are different in their arrangement or perhaps their shape. We'll look at that, maybe their shape. What you have then is two different molecules, even though their formulae might be the same. And as a result, they're going to have different properties, chemical and physical properties. So an example for this might be ethanol, for example. And instead of ethanol, you might have, that's an O, this molecule. If you count them, they're the same number of carbons in each one. There's the same number of oxygens in each one, and there's the same number of hydrogens in each one. But this is an alcohol and this is not. And this will have different chemical and physical properties to this. So this is an example of an isomer. Okay. So the next thing to talk about is the fact that isomers can be of two different types, well, 5 different types. There's 5 different kinds of isomers, and they fall into 2 categories. So we might have something called structural isomers. The first type of structural isomer is the chain isomer. So I'm going to go with skeletal representation now. If you need to recap that, we've done it in lessons past, but it's the idea that we can represent, for example, this molecule has 1, 2, 3, 4 carbons, and the hydrogens are all in third. We might have this, or we might have this. This is the linear chain molecule, and this is what we call a branched molecule. So this has 1, 2, 3, 4 carbons in a row, and this has 1, 2, 3 carbons in a row, and a branch coming off to include the 4th carbon. Same number of types of atoms, different molecules, different structures, and these ones are called your chain, your linear or your branched types, and they're types of chain isomer because you can have the linear chain version or the branched version. Another type of structural isomer might be, let's have a look, your position isomer. This is where just the position of something in the molecule is different. So I might have hexane, but actually maybe it's hex-1-ene because it's got a double bond here. A position isomer of this might be hex-2-ene, where the position of the double bond has changed. So again, same number of types of atoms, but the positioning of one of the functional groups is different. So we have two position isomers. This is again a type of structural isomer. What's that, Felix?
You have 5 minutes.
Thank you. We've got somebody timing for me upstairs. Okay. We also have the functional group isomer. This is another type of structural isomer where the structure of the molecule is different in the two cases. The structural isomer that I will show you, this is a type of functional group isomer. If you are referring to your functional group chart, you will know that this is a carboxylic acid and we have a chain of 1, 2, 3 carbons. So this is propanoic acid. If we restructure this a little bit like taking Lego pieces apart and rebuilding them in a different way, we might have this one instead. So effectively we've taken this carbon and we've stuck it on the other side of the oxygen, and now instead of a carboxylic acid we've got an ester, but isomers, same number and types of different atoms, different structure, and this type is called the functional group type. So those are your 3 types of structural isomers. You've got the chain, the functional group and the position. The other category that our 2 other types of isomers fall into are this one. The next type that we have is a geometrical isomer. So this happens when you have a double bond. So we've got a carbon and a carbon sharing a double bond here, and each carbon is making those 2 bonds and 2 single bonds. Let's say that we've got something like this. So this type is called geometric. This is a geometric isomer. It's to do with the geometry of this molecule. This molecule is locked in place. This double bond, there's no rotation around this bond. Around single bonds you get free rotation, but around a double bond it's kind of locked in this position. So this one has locked with your 2 hydrogens up here and your carbons down here. What we imagine for this is we imagine kind of an invisible line running through there, and we look up here at this half and we say the 2 kind of similar groups are on the same side of this double bond, and we call this the same isomer, or cis. Cis means same, because these 2 similar groups are on the same half of this double bond. The other version of this isomer that we could have, we can have a look at by switching these around. And in this example, our hydrogen and our hydrogen, or our CH3 and CH3, are on opposite sides of this line. And when they're opposite, we say that we have the trans isomer. So these are your geometric isomers, and you can have the cis isomer when the 2 groups are on the same side of the double bond, or you can have the trans isomer when they are kind of opposite like that. Okay, your last isomer type. This is the one we looked at when we were talking about the drug thalidomide, and how you can have isomers of molecules that are a bit like your hands. They can mirror image one another, but you can't overlay one and make them fit, so they are different. The way we've represented this is using these flying wedge diagrams. These are called optical isomers. This is your last type, optical isomers. The key thing about this, what's up, Felix?
5 more minutes.
Thank you. The key thing about this is that for this to happen, we have to have a special kind of carbon called a chiral carbon atom, and a chiral carbon atom has 4 different things at the end of its 4 bonds. So I'm just going to represent them kind of as different colours. It doesn't matter what these things are, as long as they're all different, this kind of isomer can occur. Okay, so this is one version of this isomer. This is to do with geometry. So all that you need to do to know what the other version of this would look like is pick any 2 of these and swap them over. What I always tend to do is just swap over the sticky out and the bending back one here. And if you did that, if you switched over the 2 and the 3, so that you have the 2 down here and the 3 up here, you'd have the other version of this isomer. You would have your 2 that will mirror image, but they won't superimpose like we looked at. So I appreciate that's a bit of a whistle-stop tour, but what you should have is 5 different types of isomer and an idea of what isomerism as a definition means. There's a bit of duplication to some of this stuff that I've done in the videos I've given you of my screen, where I'm working through some examples of these different types of isomers. So certainly watch this video again if you need to, and also watch through the screenshot videos that I've given you, and hopefully it will come together for a bit of an explanation. But if not, I will see you in Microsoft Teams.